In this module we will understand what are the different SD-WAN topologies and how the data plane traffic flows in each, the different site types, gathering requirements to create device configuration templates, types of SD-WAN topologies. In this section we will quickly review the different SD-WAN topologies that can be created on the Versa SD-WAN. SD-WAN topologies can be broadly classified into two, hub and spoke, and full mesh, depending how the customer wants their data plane to work. Hub and spoke topology. In this section we will look at what is a hub and spoke topology, and what are the different flavors we can configure in hub and spoke topology. The flavors essentially define how the overlay tunnels are going to be formed, and in turn define how the data plane communication takes place. There are three flavors to hub and spoke topology, and they are hub to spoke only, spoke to spoke direct, spoke to spoke via hub. Hub and spoke topology, hub to spoke only. In this topology the dynamic tunnels, SLA, are formed between the spokes, and the hub only, and there is no spoke-to-spoke communication, either directly, or via the hub. This is a typical architecture where all applications are hosted in the hub location, and no two spokes, or branch locations would require communication between each other. A typical use case could be a banking customer, where transactions happen only with the data center or hub, which hosts the banking applications. Or another classic case would be stock market, which will typically have all its dealers, or stockbrokers access the Bourse application only, to do trading. Hub and spoke topology, spoke to spoke direct. In this topology, spokes will form SLAs with the hub, and also individual spoke locations, like they do in a full mesh topology. Also DTVI, or the data path tunnels are also created. Spokes will reach the hub for accessing centrally hosted applications, but will continue to have direct spoke-to-spoke traffic for any communication between the spokes. The advantage of using this topology is that there is a backup in case of a diagonal transport failure between two branches. Diagonal failure is a case where transport 1 fails in spoke 2, and transport 2 fails in spoke n. Now assuming that the transports used by the branches are non-internet, say two different provider MPLS providers, they will not be able to form an SLA between the branches. In such a case the spokes will continue to have their SLA up with the controller, and in turn with the hub on the single transport link that is up, and the spoke-to-spoke communication will continue via the hub. Hub and spoke topology, spoke-to-spoke via hub. In this topology, all spokes will form SLA with hub only, and any spoke-to-spoke communication will take place via the hub. The typical use case is one where a large network is deployed as hub and spoke, and end branches will need to access application only in the DC. Full mesh topology. This is the simplest of all topologies. Dynamic point-to-point tunnels or SLAs are formed between all the branches, each branch has a DTVI towards all the other branches. All branch-to-branch traffic will go directly between them. Site types. In this module, we will look at what are the different site types and what would be the typical deployment type at these sites. In any network there would be different site types and they can be broadly classified as hub or DC sites, large branches or HQ sites, small branches. This classification also defines in general the type of deployment to be done at these sites, if it would be a single CPE, or a high availability deployment, and also other features that need to be provisioned. Hub sites. These are sites which are generally co-located at the customer data center. It can be a hosted data center or customer-owned. The SD-WAN deployments here are generally done in high availability, using 2 CPEs. This gives a device-level redundancy. A typical hub or DC deployment would be behind a perimeter firewall and the LAN side having the server farms and a separate LAN for the users who work in the data center. However, The perimeter firewall is in itself not necessary as the Versa appliance is capable of blocking any attacks. Placing the device behind the firewall or not is a customer decision. There could be multiple transports that would be in place, could be a mix of MPLS and internet links. Given that this is a hub or DC colo site, ADIA may not be applicable but can be provisioned if it is required in the design. When we deploy a high availability setup, we would have to run VRRP on the LAN. A DC environment will typically have a dynamic routing protocol running on the LAN, and it might have to be extended up to the SD-WAN LAN as well, or in some cases if the customer has an inside firewall then we will run dynamic protocol, or configure static routes pointing towards the firewall. These details will have to be captured, and the inputs translated into a device configuration template on the Versa director. After this, the important part is the feature tier subscription for the site. Depending on the features the customer has subscribed, it could be from plain vanilla SD-WAN to secure branch with NGFW and UDM. We will have to capture all this information, and these will essentially translate into a requirement gathering form. Click on Resources at the top to access a sample form. Head office or HQ sites. These are critical or important sites in the customer network, AHQ or regional HO, and typically these sites will also have a high availability deployment, though not mandatory. In addition to HA, these sites could have multiple LAN networks separating different functions within the branch, separate LAN VRs. Policies will have to be defined for each of them, like DIA for some, and no DIA for the rest. So to create a AHQ template, we will require similar to the DC, the IP scheme, number of transport links, and in addition services like DHCP, number of LAN networks, and the policies applicable for each. Will ADIA, direct internet access, need to be enabled for any of the LAN networks? All the features enabled will be as per the license tier subscribed for. Click on the Resource tab on the top to access a sample form. Small branches. These are branch office and generally have single CPE deployment with redundant transport links and typically will have a requirement for DIA. We will require the transport details as well as DIA policies and any other features that need to be enabled. In this module we discussed what are the different SD-WAN topologies and how the data plane traffic flows in each, how the overlay traffic flows in ideal state and when there is a diagonal transport failure. Gather requirements to create a device configuration template on the Versa director.